Good evening, everyone. Very good evening. Am I audible to you all? Okay, guys. Okay. So we shall start with our today's class, and whatever yesterday we have done, again I'm gonna repeat all of it. So don't have to worry if you. I mean, yesterday I have taken a little 45 minutes late. So I'm gonna repeat what all I have done in yesterday's class. I'm gonna repeat it again. So make sure you guys go through it. Okay. Okay. One second. Okay, let us proceed with our concept. So in the last class, we were understanding reference variable. We were understanding a reference variable. We were understanding reference variable in the last class, and here here if you take one student object, one student object can be referred with multiple reference variable. Multiple reference variable. One student object can be referred or referenced with multiple reference variable. Okay, so we can copy the reference. Okay, we can achieve it by copying the reference of one object into another object. So let us see how it is possible. So if you create a student object like student yes is equal to new student of no argument constructor. Now student S, assume the S variable has an address 0x1. Okay, and I'm creating one more object, a student S1 is equal to yes. I'm copying the address of S inside the S1. So what is address of S? 0x1. That 0x1 is stored inside S1. 0x1 is stored inside S1. Okay, and inside S1 currently we have 0x1. So one object address we have copied in another object address. Like this yes address of this variable yes we have copied in S1. And if you can take one more student S2 is equal to yes. What we are doing? Same S variable data only, that is 0x1 it is stored. 0x1 is stored in S2. So now if the S is pointing towards the address, assume this is an object now. Now S is pointing towards the 0x1. S1 is pointing towards 0x1. S2 is also pointing towards 0x1. Okay. S1, S1, S2, and S. Okay. Yes, S1 and S2, all three are pointing towards this same object, same student object. See, once for variable S, we have created an instance, and now S is also pointing towards that. S1 is also pointing towards that, and S2 is also pointing towards that object. Okay, so like this you can refer. Okay, you can refer one object, or you can point towards one object, you can access one object with the help of multiple reference variables. You can access one object with the help of multiple reference variable. Okay, and the rule here is, if you are storing the address of one reference variable inside another reference variable, if you're storing one reference variable inside another reference variable, the type of the data type should be same. The type of the data, okay, the data type of that variable should be of same type. Data type, data type of that variables should be of same type. Okay, what is the rule here? Here, if you want to copy, no, It is not reinitialization. See, to the same variable, if you are doing, okay, if you are doing s is equal to new student, it's something like that. For the variable s, if you are doing anything, that is reinitialization. But here, for s1 we are doing initialization, for s2 we are doing initialization, for s we have created an object. Suppose if for this variable again if you do initialization, that is called as reinitialization. That is called as reinitialization. Currently none of the elements are on reinitialization. Okay, we are just initializing members directly, one time initializing. For s1 we are initializing one time with s, for s2 we are initializing one time with the variable s. Student s is equal to new student of no argument constructor, and student s1 is equal to s, which means address of s variable is stored in s1, and address of s2, I mean address of s2 is taken from s only. So s, s1 and s2 is pointing towards the same object. Okay, this is how one object can be referred with multiple reference variable. One object can be referred with multiple reference variable by copying the reference of, by copying the reference of one object into another object. We can achieve this, we can achieve this condition, that is one object will be referred by multiple reference variable, multiple reference variable. Okay, so here the rule is, if the reference variables of same type, see s1 s2 s3 was there, no, I mean yes s1, yes s1 s2 was there. Now since yes s1 s2 are of same type, they are of what type? Student type. They are of same type only. So since they are of same type, they were able to, they are able to get the address. Okay, they were able to initialize with the, they are able to initialize with the address, they were able to initialize with the address. But if I'm taking one student object, student s is equal to new student of no argument constructor. Now if I take student s, student s1 is equal to s, I can easily store it. But if I take, if I take teacher object, teacher t is equal to s, is it possible? Is it possible? Of course, no, it is not possible. It is not possible because S type is student. S type is student. So S type to S type, okay, we can easily store. Since this S is of student type, this S1 is also of student type, we can easily share, or we can easily initialize the this variable with the S. Okay, so that the address also will be stored in S1. But here, if you want to store the address of variable S inside the T, the type of teacher is what? Type of T is what? Type of T is teacher. Type of T is teacher. So since the type of T is teacher, since the type of T is teacher, we will not directly store the address of S inside T. We will not be able to store the address of S inside T because we have to do type conversion. We have to do type conversion. Student, you can't, student address you can't store in teacher address. Okay, teacher reference variable. Student address you can't store in, you can't store in teacher reference variable. Okay, so for this type conversion is needed, that is student type you have to convert it into teacher type, student type you have to convert it into teacher type, or teacher type only you have to convert it into student type, anyone you do, but both of them should be of same type, then only we can store. Okay, or else we cannot store. Okay, so because of this, okay, to achieve this, okay, to achieve this we will be going for your non-primitive type casting. To understand how it can be casted or type casted, we'll be going for our non-primitive type casting. Okay, we'll be going for our non-primitive type casting. Okay, so let us go here. So today we'll be learning about non-primitive type casting. Non-primitive typecasting means it's a process of converting one reference type into another reference type. It's a process of converting one reference type into another reference type is called as typecasting. Okay, and there are few rules you have to know before going to achieve this non-primitive typecasting. Okay, the rule is, first rule is there should be an easy relationship between the two classes. if you are doing casting, type casting, there must be there must be an easy relationship. There must be an easy relationship between those two objects. Second one, there should be a common child for a class or interface. There should be common child for for class or interface. For class or interface, there should be a common child. There should be a common child for both class or interface. Okay. And we have seen how with the help of single level, multi-level, the inheritance will, the conversions will go on. Okay. So yesterday we have seen the fruit and the apple, right? And we have also seen vegetable and the carrot. So it's a single level inheritance. Okay, we shall take this class as a class fruit. Then we go for class apple. We have class vegetable. We have class carrot. Now we have taken this, and here listen carefully. In here we have a class fruit. Class fruit can be converted to apple. Apple can be converted to fruit. Fruit can be converted to apple, and apple also can be converted to fruit. Vegetable can be converted to carrot, and carrot can be converted to vegetable. Vegetable can be converted to carrot, and carrot can be converted to vegetable. Okay, and here fruit and apple cannot convert it into vegetable and carrot. Fruit and apple cannot convert it into vegetable and carrot. In the same way, vegetable and carrot cannot convert into fruit and apple. Vegetable and carrot cannot convert it into fruit and apple. This is on in a single level inheritance will go on. Okay, and coming to hierarchical inheritance, one parent and more than one child class. One parent and more than one child class. Okay, now so class A, if we take a class, it has fruit, apple, and mango. Fruit, apple, and mango. Here, currently we have class fruit and we'll have two children, apple and mango. Fruit can be converted to apple. Apple can be converted to fruit. Fruit can be converted to mango. Mango can be converted to fruit. And apple cannot be converted to mango, and mango cannot be converted to apple. Apple cannot convert it into mango, and mango cannot be converted to apple. Okay. So this is about a hierarchical inheritance. Now let us go for multiple inheritance, wherein we have two parent classes. We have two parent classes and one child class. One child class. Okay. So there is a relationship going on here. So suppose guys, just a minute, I'm getting a call. Excuse me. Yeah. So currently we are going for your multiple inheritance. So A we have, B we have, and C we have. So here you can convert A to B, you can convert B to A. You can convert B to C, and you can convert C to B. You can convert A to C, and you can convert C to A. Okay. This is how you can do a type conversion in here. Okay. In the multiple inheritance. Currently it is not possible now. When we go to interface, it is possible. Okay. So this is about your conversions, like how with the multiple inheritances, okay, like with different inheritance, how it will be, I've shown you. Okay, now let us understand the non-primitive typecasting now. Okay, non-primitive typecasting or derived typecasting has two types further, that is upcasting and downcasting. Upcasting and downcasting. So upcasting means what? It's a process of converting. Okay, it's a process of converting child class reference into child class reference into parent class reference. Parent class reference. Okay, upcasting means it's a process of converting child class reference into parent class reference. Conversion of child class reference into parent class reference is called as upcasting. Okay, and how can we indicate this upcasting? Very simple. Assume you have two classes here, class fruit, class apple. Okay, now this apple reference, okay, apple object reference, if it is upcast to class fruit, if the apple object reference, if the apple object reference is the upcasted to class fruit, then we call it as a upcasting. Okay, that is apple object is converted to fruit type. Apple object is converted to fruit type. This is called as upcasting. So if you create an object for apple, apple a is equal to new apple of no argument constructor. Now go for fruit object, because we are converting apple reference to fruit reference type. So we'll go for fruit f is equal to, we'll copy the variable a. We'll copy the variable a. Okay, but why we have to copy the variable a? Because here, here we are converting the reference of from apple type to fruit type. We are converting the child reference apple from apple type to fruit type, we are converting. Okay, we are casting. Okay, this is called as upcasting, wherein child class apple is converted into a child class reference variable apple is converted into parent class reference. Parent class reference is called as upcasting, is called as upcasting. Okay, now here you have to know few things about upcasting. See, this upcasting is implicitly done by compiler. Implicitly done by compiler. Okay, and since it is done automatically by the compiler, we call it also as a auto upcasting. We call this also as a auto upcasting. Okay, and you can also do upcasting with the help of typecast operator. You can also do upcasting with the help of typecast operator, and and here once the reference of child is upcasted to fruit, that is once the reference of apple, okay, it is converted to fruit type, it is upcasted to fruit type. You are here, okay, the control is here in the fruit class. Now you can't access child class apple members. Now you can't access child class apple members. Okay, so this is one drawback of upcasting. Upcasting drawback is that is once the child class reference is upcasted to parent, okay, from the parent class you can't access child class. From the parent class you can't access child class. That is a rule. Parent will not access child. Parent will never access child. But child will access parent. Okay, child will access parent. Now here, apple to fruit. Okay, what's happening is we are converting apple type reference into fruit type. Okay, apple type reference into fruit type we are converting, and after that here, once the reference of the child is upcasted to parent type, you can access only parent members. You can't access child members. Okay, that is the drawback here. And this is how you do upcasting. This is how you do upcasting. Okay. So first of all, why do we need this type of upcasting and all? See guys, we need upcasting, okay? We need upcasting for mainly one thing, for achieving generalization. For achieving generalization. For achieving generalization, we need upcasting. For achieving generalization, we need upcasting, okay? And so why we will go for generalization is because it helps to create a generalized container so that the reference of any type of child object can be stored. The reference of any type of child object can be stored. Suppose if you take three classes for as a child, if you have a class cab, if you go for mini, macro, and a prime, all these three are same. So you can go for cab here, cab, mini, macro, prime. Okay. See guys, whenever you go for booking a Ola or Uber, you get three options: mini, macro, and prime. Now, tell me, if you choose mini also, your cab will be booked. If you choose macro also, your cab will be booked. And if you choose prime also, the cab will be booked. So, am I correct here? Is it correct? If you click mini also, you'll book the cab. If you click on macro also, you'll book the cab. And you will, if you choose for prime also, you'll book the cab, right? Yes. So that is why whenever you choose mini, okay, mini will be upcasted to cab type. Mini will be upcasted to cab type. Whenever you go for the macro, macro will be upcasted to cab type. Whenever you go for prime, prime will be upcasted to cab type. Okay. So now we can achieve here. Okay. How you can achieve is very simple. First you have to go for generalized container, that is cab C. Cab C. Okay. Now this is how you create a generalized variable. Okay, this is how you create a generalized generalized variable. Okay, and you have created generalized variable. Yes, we have created generalized variable. Now with the help of this generalized variable, we can easily upcast any class, I mean any child class to this parent class. Okay, so now let us start it. So c is equal to new mini of no argument constructor. See, inside one new keyword, what is there? Address is there. So that address is stored inside variable C. Address is, the whole object address is stored in variable C. It's like, listen carefully. So instead of just creating object and giving here, you can do like this also. You can go for mini object, mini m is equal to new mini of no argument constructor, and you can give this variable m. C is equal to m, you can give. C is equal to m, you can give. But you don't have to do this step. You can just create an instance and a constructor. Okay. You can just create an instance here, and the address of this mini object will be upcasted to cap type, okay. Next c is equal to new mini, next c is equal to new macro, and c is equal to new prime. Okay, so this is how you do upcasting. I upcasted mini to cap type, upcasted macro to cap type, and upcasted prime to cap type. Okay, so this is how you achieve up. This is the need of achieving upcasting. That is to create a, I mean to achieve a generalization and to create a generalized container. Okay. See, the drawback of upcasting is after upcasting, you can't access child class members. After upcasting, you can't access child class members. So because of that only, we have to go for downcasting. Downcasting means, okay, downcasting means very simple. Downcasting means it's a process of converting a parent class reference type into a child class reference type. Okay, downcasting means it's a process of converting parent type reference into child type reference. Parent type reference into child type reference is called as downcasting. And we need downcasting because after upcasting we will not be able to access child class members. So to access child class members, we have to bring down the control from parent class to child class. You have to bring down the control from parent class to child class. So this is why we go for a downcasting. We have gone for downcasting because to overcome this problem. The problem is after we go for upcasting, you can't access child class members. You can't access child class members. Okay, and so you have done upcasting right now. How can we do downcasting here? How can we do downcasting? Okay, see, you have to know some more things about downcasting. So first, let us learn about that. See, downcasting is not implicitly done. Downcasting is not implicitly done. It has to be done by the, it has to be done by the programmer. It has to be done by the programmer. Compiler will not do it by default. Compiler will not do it by default. Only the programmer has to go for downcasting. Okay. So downcasting is not implicitly done by the compiler. It should be explicitly done by the programmer. Okay. And downcasting here, um, excuse me. Okay. This is our downcasting. Okay. So the reason for downcasting is once the reference is upcasted, in order to access child class members, it's not possible. So we will be doing downcasting to order to order to access child class members. We'll be going for downcasting. To access child class members, we'll be going for downcasting. Okay, so here you can do downcasting in this way. Okay, let me show you here. Okay, let us take any elements, maybe 1 second. Okay, assume you have a carrot vegetable class. Okay, I think yesterday we have done carrot and vegetable only. Okay, let it be class vegetable class carrot. Okay, here we have inheritance going on between vegetable class and the carrot class. So carrot is a vegetable. Carrot is a vegetable. Carrot is a vegetable. Okay, and and next. Okay, next after this, now let us do both upcasting and downcasting here. Okay, let us do both upcasting and downcasting here. Okay, so now let us go for your upcasting and downcasting. For first, before that, let us create an object for child class, that is carrot c is equal to new carrot of no argument constructor. Now, can anyone tell me how do you do upcasting here? How can we do upcasting here? How can we perform upcasting here? Formula I am asking, not extends keyword. Keyword I we know everyone. How can we perform upcasting now? Yes, correct. Vegetable v is equal to c. So variable type c will be storing inside vegetable v. Okay. Here it's a upcasting. So easily you can do without typecast operator also. Okay. If it's needed also can take, or without that also it will work. Okay. So vegetable v is equal to c. Okay. Now we have done upcasting. Okay, from vegetable to carrot. Now let us go for downcasting. Okay, downcasting means, upcasting means conversion of carrot to vegetable type. Okay, so carrot type we have converted to vegetable here, that is called as upcasting. Downcasting means vegetable type only you have to convert it into carrot type. Vegetable type only we have to convert it into carrot type. So why we have to do that? Why this type conversion is needed? This type conversion is needed because after upcasting, you'll not be able to access child class members. To access child class members, again will be downcasting. Again will be a downcasting. Okay. So here what's happening is, so we have created an instance of carrot c is equal to new carrot. Okay, now new carrot constructor. Now vegetable v is equal to c, that is parent class reference in here. Okay, that is called as upcasting. Now how can we do downcasting? Since we are converting from vegetable to carrot, so we have to create for we have to go for carrot variable. Carrot c1 is equal to this variable will be taking here, because we'll be converting vegetable to carrot. So to which type we are converting vegetable to? Vegetable we are converting to which type? We are converting to carrot type. We are converting into carrot type. Okay, so we shall go for carrot variable here. I mean carrot word. Can you see here? Carrot c1 is equal to, okay, carrot of v1. Carrot of v1. I mean we have variable v now. Okay, so carrot of v. Now this is how you create an instance for child, and this is how you do um, upcasting, and this is how you do downcasting. This is how you do downcasting. Okay. Now, here we have just created an instance, and we have created an vegetable object, and we have stored the address of the variable c inside v, and we have done the same with the class carrot. So carrot c1 is equal to, now inside the carrot, inside the brackets of carrot, now currently there is few objects of the class carrots. Okay, so carrot c1 is equal to carrot of vegetable v. That means vegetable we are converting first to carrot type. Okay, you can't directly reinitialize, that is downcasting. No, you have to go for vegetable v into, you have to convert it into carrot type. Okay, you have to convert it into carrot type, and then only you can do downcasting. That is, you can access the child class members, and through the child class members only you can access the parent class members as well as your own members, or else your this class own members you can access. Okay, so this is about your upcasting and downcasting. And there is one more problem in downcasting. See guys, from which class we have upcasted? No, from which class we have upcasted? No, suppose assume we have class A, B, and C. If you have upcasted from class A, okay, I mean from class B. Now guys, tell me to which class you have to downcast? If you have upcasted from class B, to which class you have to downcast now? Yes, A. Here, here, yeah, class A is correct. So if you have upcasted to class A, you have to downcast to class B. If you have upcasted to class A, you have to downcast to class B. If you have upcasted through class C, if you are upcasted to class C, and if you're downcasting to class C, that's fine. But if you're upcasted from class C and downcasted to the class A, downcasted to the class A is called as, excuse me. Okay, so just a minute. Excuse me, guys. Okay. Okay, so this is called as upcasting only. Okay, so here you are converting parent A to, okay, I mean you can convert child B to parent A, and parent A to child B can convert, and parent A to child C, and child C to parent A can convert. Okay, and the thing is, If you're upcasting from class A, I mean from class B, if you're upcasting from class B, you have to downcast to class B only. If you're upcasted to class A, if you're upcasted to class A, you have to downcast to class B only. And if you upcast from class C, if you upcast from class C, you have to downcast to class C only. If you have upcasted from class C to class A, if you have upcasted from class C to class A, you have to downcast to you have to downcast to class C. If you're upcasting from C, if you're downcasting to C, that is how inheritance goes on. But here we have one problem. Here we have one problem. The problem is, if you upcast to class A, that is from class B to class A, if you're upcasting, and you are not downcasting to class B, but you are downcasting to class C. You're not downcasting to class B, you're downcasting to class C. That means upcasting is one from one class and downcasting is to another class. Upcasting is from one class and downcasting is through another class. So this is what we call these things. Whatever happens now here, if you're upcasting from one class and you'll be downcasting to one more class. This is wrong. Okay, this is wrong. If you upcast to one class, you have to downcast to the same class. If you're upcasting from one class and if you're downcasting to one more class, here you will not get diamond problem. Here you will get a class cast exception. You will get a class cast exception. Diamond problem, it will not come. This is hierarchical inheritance. This is hierarchical inheritance. Okay, so if you're upcasting from one class and if you're downcasting to one more class from which you are not upcasted, if you're upcasting from one class and if you're downcasting to one more class, you will get a class cast exception. You'll get a class cast exception. That is, from which class you have upcasted, no, to the same class you have to downcast. To the same class you have to downcast. Okay, and let us see an example here. So assume you have an object. um okay, we'll take class parent and class child only. Now, parent, child. Okay, now while downcasting, what happens? See, we will not directly go for upcasting. Directly, if you do downcasting, also same problem happens. Okay, if you're upcasting from one class and if you're downcasting to one more class, instead of doing that, we can directly downcast without upcasting here. Okay, so how can you do downcasting? Child C is equal to child of new parent of no argument constructor. New parent of no argument constructor. So what's happening here is, in the new parent of no argument constructor, we have address of the object. We have address of the object. We have address of the object and here, since we have the address of the address of the object will be first changed to child. The address of the object, okay, the address of the object will be first change it to child, and then the address is stored in child variable. Okay, the address of this instance of parent class should be first changed to the child, and then only that address will be stored in variable C. It will be stored in variable C. Okay, so this is what we call it as a class cast exception. This is a condition wherein you will have a class cast exception. That is, without upcasting, you can't do downcasting. Without upcasting, you can't do downcasting. Okay, so this is how you will be dealing with your upcasting and downcasting. Okay, so in our last class, okay, I hope you guys have understood because 2 to 10 we have repeated. So in the last class we have done one program, right, regarding is a relationship only. This regarding this concept only we have done. I think we have done vegetable, veggie and carrot. So let this open. Just a minute. Okay, everybody understood what is upcasting and downcasting? I didn't ask it. Yeah. Yes, guys, did you get it? What is upcasting and downcasting? Everyone? Okay, guys. So we have also, yeah, we have also done one program for that. Okay, where it went? Yeah, here it is. So we have taken a class wedges. In a class wedges, we have two attributes: vname and color. We have a constructor for wedges, and we have wedgie details method. And we have class caret extends to wedges, and and here, since our parent class wedges has attributes, we have to create a constructor here. We have to create a constructor, and parent attribute parent class also has a constructor. Parent class also has a constructor. So here we have to create a constructor, and within that constructor, within the super call statement, I'm using the super call statement, we have to call parent class constructor. Okay, so class caret. So we have a caret constructor here, and using the super call statement, we are calling the parent class constructor. Next, we have a caret details method. So this many we have. Now we have created an instance for the class caret. We have created an instance for the class caret. Now, if you are calling from the child class, I mean from the class child, child class caret, from the class caret, if you're calling caret details method, neatly you'll get this, and you'll be getting it as a carrot and orange. Okay. Now, if you call widget details, that is parent method also. If you're calling parent method also, same data you will get. Why? See, after we have called c dot caret details, okay. So what happens? You're calling c dot caret details. Okay, it got executed. But before that, here since you have created a constructor for caret, so this constructor will be called, and here vname caret and a v color orange will be there, and using the super call statement we are calling parent class constructor. Now since we are calling parent class constructor here, okay, here since we are calling it, now this will be called, everything loads, everything executes, and this programmer written instructions also will execute. While passing wedges only, we have passed the data using super call statement. We have passed the all the data we have passed, and that is why this wedges constructor is executing. And in the wedge details method, obviously same vname and v color only we have taken, so we'll be getting here carrot and orange. Okay, carrot and orange. So let me show you here. Are you getting carrot and orange two times? Yes, you are getting. Now after this after this, if you call veggie also, if you call carrot details also, you'll still get the same. Okay. And upcasting, now how can we do upcasting? Upcasting, if you do, child reference will be converted to parent reference. Child reference, okay, the child object reference will be converted to parent object reference. Parent object reference, that is caret c to wedges we are converting it directly. This is called as upcasting. And using upcasting, you can only access the parent members of parent class. Okay, during upcasting you can access only the members of class parent. Okay. Now, so v dot wedgie details method, we were not able to call this caret details method because it is from the class child. Okay. Now from the parent class you have wedges constructor, and here, if as you can see here, only wedgie details methods we have. Okay, here only wedgie details method is there. Other than that, no other method is there. We have wedgie details method. Where is wedgie details method present here? In the class wedges. In the class wedges it is present. In the class wedges it is present. Okay, and after that, here we have done upcasting, that is converting child type reference into parent type is called as upcasting. And if you call wedgie details method, neatly you will get the output, that is your caret and name is orange hair. Can you see carrot and orange hair? Yes, these two will be, these two will be called. And you will not be able to access this carrot details method. You will not be able to access this carrot details method. Why? Because after upcasting the child reference to parent type, after upcasting child reference to parent type, after upcasting child reference to parent type, now, now you can only access parent class members. Since the, since the uh, conversion has happened, that is child class. Okay guys, just a minute, your counselor is calling. Okay guys, we'll resume back after requirement announcement. Yes, Varshita can carry on.
Thank you, ma'am. Good evening, guys. This is Vashita from announcement team. Am I audible to everyone, guys? Guys, am I audible to everyone? Okay. So, guys, here's the generic requirement. So, please take a snap of this, everyone. So, if you have excellent communication and gaming passion, so you can register for this requirement, guys. Both the testing and development students both can register. So, how to apply? In the QTalk app, there will be HRs. If you are a testing student, as if I told, so Sirisha and Mamta, you have to drop a message to them, your name, contact number, and the company code. So, I'll stop sharing the screen now. So, any doubts? Okay. So, these are the update for the today's class, guys. Thank you, guys. Thank you, ma'am.
Okay guys, so we'll resume back. So I was telling you that if you upcast, child class reference will be converted to parent class. Child class reference will be converted to parent type. So from the parent class, you can't access child class member. That is a drawback of upcasting. So that is why we'll be doing downcasting. That is why, that is why we'll be doing, that is why we'll be doing downcasting. Downcasting. Okay. So in downcasting, what you have to do is you have to convert parent type reference to child type. You have to convert, you have to convert parent type reference to, parent type reference to child type. So child type reference type is how much? What is that? C, caret C. Now caret C is equal to, you have to convert this parent variable v into child type first. I mean, sorry, caret type first. So you have to convert into caret type first using a typecast operator. You have to convert the variable v, that is this which is v. Okay, you have to first convert it into caret type, then you have to store in caret variable. This is the things happening when you are going for downcasting. Okay, this will happen when you go for downcasting. Okay, while downcasting, you can't just directly downcast. I mean, you have to first convert the, convert the variable v, that is parent reference variable. Okay, parent reference variable, first you have to convert it into caret type, then you have to store in c, then you have to store in c. Okay, so see, variable already I have declared here, I have declared caret c here. So again I am reinitializing it. Okay, I am reinitializing. C is equal to caret of v, c is equal to caret of v. Okay, so here, here we are doing downcasting. Now after downcasting, you can access all the members of parent also, all the members of child also. Okay, so child class members, parent class members, both the members will be able to access using a child class reference. Okay, so after downcasting, now if you're able to access both the methods, that is, you'll be able to access carrot details as well as vegetable details. Okay, using c dot carrot details method, c dot veg details method, both you'll be getting the output now, because you have downcasted, because you have downcast. As you can see here, carrot orange. Here we have access the child class members. Okay, child class members, and inside child class, obviously by default parent is also taken. Okay, so you can access the parent class members using a child class. Okay, see, it's very simple here, very simple, try to understand. Okay, the thing is, you have parent class. One second. You have parent class as well as a child class, and class parent and class child. If you want to convert child to parent, you'll go do upcasting. But if you want to access child class members, that is not possible now. After upcasting to parent type, the reference will be changed to a parent type. Then from the parent type, you can't access child. From parent class, you can't access child class members. So what we'll do is, we'll be going for downcasting. We'll be doing for downcasting. So while downcasting, easily you can access, the control will be in child class. Control will be in child class, and after the control will be in child class, you can access parent members also, its own members also. It can access parent members also it can access, and as well as your child members also it can access. That is the uses of your class child. And same thing is happening here also. Okay, that is your parent class, I mean the control is upcasted to parent type, then you will be accessing a veg details method only. But after you downcast, control is in child, and from the child class you can call the its own members. Okay, the using child class you can call its own members, and you can even access parent class members. You can even access parent class members through the methods. Okay, the method called statement. Okay, so this is about your single level upcasting and downcast. This is how your upcasting and downcasting works. Okay, I hope you guys have got it. Yes, everybody understood the program? Everybody understood the program? Let me know. We will do one more programs. We will do. Okay, guys. We will do one more program. Understood? Okay. So you can take any parent object and any child object. Okay. So okay. So we shall take one class, and we shall name it as a what will take. Okay, fruit is already there. Um, we can take as smartphone and okay, we'll go for Samsung class, and we'll also have a smartphone class. Okay, so class smartphone class smartphone. So in the class smartphone, we can have attributes. Those are smartphone will have a brand. Okay, string brand. Okay, and you can also have a price, double price, double price. Okay, now we shall have a constructor for this. Class smartphone. Let's go for source generate constructors using fields. Generate. Constructor is done. Now let us go for method, that is smartphone details. We'll go for public void smartphone details method. You can go for brand, then we shall go for price. We shall go for brand and price both. Okay. So now we are done with class smartphone. Now let us come to class Samsung. So Samsung extends smartphone. Samsung extends smartphone means Samsung has an easier relationship. Samsung is a smartphone. Samsung is a smartphone. There is an easier relationship. Okay. Samsung is a smartphone. Samsung is smartphone. Okay. Then now here, since we have a constructor in the parent class smartphone, since we have constructor in parent class smartphone, we will also have to create a constructor in the child class. We should also create a constructor in the child class. Okay. So how can we do it? Very simple. Take a cursor and keep on this, and it will also will give an option to create a constructor. So Samsung constructor we have created. Now after this, we'll be going for we'll be going for Samsung details method. So public void Samsung details method. Okay. So yes, we'll be doing Samsung details method. Now in the Samsung details method also, you have to print only the brand as well as the price. Okay, you can go for printing brand and the price. Brand and the price. So let us print it. Okay, so this is about our Samsung details method, and let us go for your main method here. So we do have a main method. Now let us create an object for class smartphone. Smartphone yes is equal to okay, we will first go for child Samsung. Okay, Samsung yes is equal to new Samsung of no argument, I mean parameter is constructor. So here Samsung, obviously you have to take a brand here. So brand Samsung Galaxy Note 5, and we shall go for price. Okay, okay, then this much is enough. So price we can take, we have taken as a double. Okay, fine. Now here. So currently we have a class Samsung Galaxy Note 5. Okay. After that we have an attributes 4500. Now using variable yes dot, we can call it a smartphone details method. Okay. You can call smartphone details method. Why? Because using a Samsung constructor, you have called the parent class Samsung constructor, and through the supercall statement, you'll be able to access the parent class constructor, and you'll be able to initialize those attributes. You'll be able to initialize those attributes, and after initializing, obviously, your brand and price you'll be getting a brand and price. Okay. So after this, now If you go for printing s dot smartphone details also you'll get same output, and if you go for s dot Samsung details also you'll get same output, because control is in child class. Through child class you can access the parent class also, its own class also. Okay, through the child class you can access its own members as well as a parent members also. Okay, so now let us see here once again. Hmm, Samsung already defined. Okay, we'll change this as a smart gadget. Okay, smart gadget. Or else we'll go for gadget only. Smart gadget, and here same thing we'll go for, because same type we have some more classes, so that's why it is showing error. Smart gadget, and here Samsung 16 smart gadget, Samsung mobile. Class name is Samsung mobile here. Okay, so there is a Samsung mobile constructor now. But why is it not changing here? Okay, Sam mobile will take. But still we are getting error. Why? Okay, we'll go for Samsung only. Let us remove all other. Okay. So we have a Samsung mobile constructor now. Okay, and using that, okay, using that method return type. Oh, what happened here? Smart gadget only we have. Samsung mobile. Everything is fine, right? Samsung mobile and Samsung details and smartphone details. Okay. So here, okay, we have Samsung. Okay, so we are trying to go for Samsung mobile. Okay, and what is this return type to void? This is a constructor. Okay, super of brand comma price. Okay, fine. Oh, it is a first statement in a constructor. Just a minute. Okay. So that is why we should not go for creating same type of elements in the same package. So we are in a relationship now. Where are we? Yeah, in relationship already. Those type of classes already we have written. So yeah, you can take whatever animal, tiger, whatever is needed. You can take whatever you want. Okay. So here, yeah, we have created an object for the child class Samsung mobile. Okay, leave all those. Listen now. we have created a object for the yo wait first listen here. You can naming, you can do whatever you want, but listen to the concept. So here we have a object for the child class object we have created. After creating child class object, through the child class reference we are accessing parent members as well as child members. We are accessing parent method also, child method also we are accessing. And now we'll be getting our output. Can you see? Samsung Galaxy Note 5 45,000, Samsung Galaxy Note 5 45,000. So here parent class also has been, I mean parent member also has been executed, and the child member also has been executed. But if you do upcasting, if you do upcasting, you can go for so Samsung, that is smart gadget s is equal to, okay, sg is equal to, yes. So we have done upcasting. When you are doing upcasting, control goes to parent type, and when control converts to parent type, and you can access only the parent class members. So using st dot smartphone details you are able to access, and st dot Samsung details you can't access. Samsung details you can't access. Why? Because from parent class you can't access child class members. From parent class, you can't access child class members. So that is a drawback. And because of the drawback only, here we are going for, downcasting, because you have to access all the members. No, so we'll be going back to same class, that is class Samsung mobile, through the downcasting. Okay, downcasting. So while downcasting, we can go for Samsung mobile S is equal to. So we'll be typecasting SG2. We'll be typecasting SG to smartphone. Okay. Will be Samsung mobile. Okay. So here, listen carefully. We have taken smart gadget, and we have converted the Samsung into smartphone. We have converted Samsung into smartphone. Smart gadget. So here it is called as upcasting. And after upcasting, you can access only parent members. You can't access child class members. In case if you want to access child class members, you have to do downcasting. Okay. And while downcasting, S is equal to Samsung mobile of the smartphone, smart gadget. Okay, so why is it like this? Okay, why is it like this? S is equal to Samsung mobile of SG. So SG is a parent type reference. Parent type reference we are storing in a child class. Okay, we are converting it into child class. That is our Samsung mobile. So first you have to convert SG, that is smart gadget, into the Samsung mobile, and then you have to store in variable yes, that is of Samsung mobile type. Okay, so after downcasting, control will be in child class. So s dot smartphone details method you can access, as well as s dot um, Samsung details also you have to access. So now if we execute, now you'll be getting both the outputs. Can you see here? Once again, can you see, are you getting same outputs? Yes, because we are able to access everything, but upcasting means converting child to parent, downcasting means converting to parent to child. Okay, converting parent to child. Okay, so why we have to go for upcasting? To achieve generalization, we have to go for downcasting. Because of a drawback that after upcasting you can't access child class members. So because of that, here we are doing downcasting. And while downcasting, okay, so what is the problem that happens or occurs during downcasting, everyone? What is the problem that happens during downcasting? During downcasting, what happens? Yes, guys, if you don't upcast directly, if you downcast, okay, what is the problem? No, we can't do downcasting directly. No. Yes, we will get class cast exception. We will surely get a class cast exception. Okay. So we will get class cast exception. So that is why we will not do downcasting directly. First we have to upcast. Okay. Excuse me. First you have to, you're having parent and child. First you have to upcast, okay, then only you have to do downcasting. Without upcasting, if you try to do downcasting directly, you will be getting class cast exception. You will be getting class cast exception. Okay. Then after this, okay, after this, I hope you have understood. Without upcasting, you can't do downcasting. Okay. So I hope everybody understood with this second example. Not class cast error, it's a class cast exception. There is a difference between error and exception, so you have to tell it as an exception only, not error. It is a exception. You will understand once we go to the exception concept. Okay. You didn't get the question now. See, if you don't upcast, okay, that means if you don't upcast and if you directly doing downcasting, that is, assume we have parent and child, we are not done upcasting but directly we are doing downcasting. Without doing upcasting, we are directly doing the downcasting. So without upcasting, if you directly do downcasting, you'll be getting class cast exception. The reason is this parent type reference will not have the access of child type. Child type should be first converted to parent. Okay, then you can have members of the um, parent members only you can access, but still the reference of child is there in the parent. So depending on that, the control will execute or downcast to the same class. Okay, without upcasting you can't do downcast, that is not possible. Okay. So always remember, without upcasting you can't do downcasting because reference variable of child has not been upcasted to parent. Okay, reference variable of child has to be casted, then from there you have to downcast. Directly you can't do downcasting. If you want to downcasting, you can do, you'll be ending up with the class cast exception. Class cast exception. Okay. So this is about your downcasting and upcasting. Okay. Hope everybody has understood. And as I remember, what is the use of this in real life? Real life, so many uses are there. So many uses are there. See, I will tell you. Okay, so we have seen one example. You remember the car and the three child, mini, macro, and prime. So the thing is, whenever you go for any booking of any mini, okay, mini means what? You will be you will be upcasted to, if you're choosing mini, you will be upcasted to car type. If you're choosing mini, you will be upcasted to car type. And if you want to downcast to mini, okay, mini address this car object have, okay, now you have to downcast to same object, you have to downcast to the same mini object. Okay, here when you're upcasting, see, whenever user chooses mini, you will be booking a car. Whenever user chooses mini, you will be booking a car. You have booked a car, but mini details you have to know. How we will know the mini details, mini car details, how you will know the car which is a mini. Okay, how you'll know the details is present in child class, no? Details is present in child class, no? Now how you'll know? By downcasting. By downcasting parent type car to child type mini, you'll be getting your, excuse me, you'll be getting your details of your mini. Okay, mini details you'll get. Okay, So this is where you'll be using in real life. If you are booking a cab, if there is a mini, macro and prime, mini, macro and a prime. If you choose mini, mini will be mini is a cab and it is booked. If you choose macro, macro will be booked as a cab. If you choose prime, prime will be booked as a cab. And and here and here you want suppose assume from mini you got upcasted. From mini you got upcasted to cab. Now one time. Now after that you have to downcast to mini only. You have to downcast to mini only. Okay. And why you have to downcast to mini? Because after upcasting you can't access mini details. After booking for prime, okay, I mean sorry, after booking for mini, you have to wait. Okay. and and then, okay, then here, see, it's very simple. Here you are trying to go for booking a mini. Okay, you are booking a mini. As soon as you clicked on mini, cab will be booked. Okay, after booking a cab, you have to narrate which cab you booked, what all the details of the cab that is present in mini. And we already know from the parent class you can't access child class. From the parent class you can't access child class members. You can't access child class members. So that is why we have to downcast. That is why you have to downcast. Okay, so after downcasting you can access the details of the car you have booked. Car is booked as soon as you go for mini will be upcasted as a car. Okay, it will be chosen as a car, but you have to show details. You have to downcast to class mini. Okay, hope you understood. Yes, Saurabh, got it. These and all in a code they will be happening. Okay, you don't have to separately see the things, everything. Okay, by default in the code only it will be happening by default. Okay, I hope everybody is clear the concept. Understood? Okay, guys. Any more doubts in this upcasting and downcasting? Because we'll be doing a design which is very important, and we'll be also understanding one instance of operator also. Understood? Okay. So guys, tell me, have we completed a mock for your? So how many parts we have done? Did we complete part one? Part one we have completed, right? Part one MCQ is done. Did we go for programming? Programming is completed. Guys, let me know. Programming is completed. Okay. So, I will share. I keep forgetting. Okay, I will share. So you have done with part one. MCQ is done. Programming test is also done. So mark is pending. Let me go for taking mark here. So I think this much is enough for today. Wait here itself. 29 people are here. Be here itself. I'm gonna take mark for everyone. I'm gonna take 2 minutes. If you leave, then it's a big loss. So make sure you are here. Okay. For how much ever is possible, I'll be taking a mark. See, for the mark separately, we can't assign one class. Okay. Like if I assign on Sunday, can you guys come attend on Sunday? Sunday, is it possible to attend the mark? Sunday, okay. What about others? Minimum 3 hours will be there. Timings, maybe morning or maybe evening. It might be. Okay, few opposition also is there. Okay. Timings can be confirmed, but Sunday, um, okay, Sunday evening 7, I might not be available to you guys. Okay, part one only. No, you guys know, right? Part one. Sunday, usually we go for Sunday for the mock. um Okay, see, Sunday one day it's not possible to take mock for all 27 of you. So we will just see half an hour is left. Okay, one and a half hour we have done the concept. Now next half an hour, how much ever is possible, we will conduct mock itself. Okay, so I think I have told you this earlier, right? I told anytime I can conduct mock, right? And as you can see here, people are leaving. People are leaving, and this is not a good thing. Sunday is not possible. See, each of you has to be here, so I don't want any of you to miss. See, people are leaving. This is not a good thing, guys. If I tell Mark why you are leaving, you have to face interviews, right? For Mark, if you are scared, then how can you face things in life? That too online. Oh God. Okay. So take on Sunday. Mm, Sunday. Okay. Okay. In one day. Yeah, that is what even I have planned. Last half an hour, if you take within 2 3 days, we can complete. Yeah, that is what I'm thinking. So, guys, enough time is already given. What will happen in 3 days? I think you guys have already studied. Everybody has cleared the test, means obviously you know everything. Okay. So we shall start your mock now. Don't worry, I am not a dinosaur. I will not eat you guys. Okay, I will not scold you. I will not tell anything. Okay. So wherever you have to correct, I'll just tell. Okay. So yes, just a minute. I'll just open your this one here. 1 second. So batch code is E23, and be here. Don't get scared. Okay. If you are not ready now, we can take tomorrow. Okay. Don't worry. Not M17. It's E23, right? E23. Why am I getting same if I click on E23? Just a minute. Once again. Yeah, got it. So I'll get to know. Okay, okay, no problem. People who are available now, you can only give mark. People who can't give mark now, it's okay. You can give tomorrow. Okay. Don't leave the class. Listen to your friends how they're responding to answers. Okay, you will get to know. Don't leave the class. So there are 22 responses, and I want all 22 of you should be here. Okay. Currently there are 22 people. People who have not attended has left, and I'm gonna share your okay, the scores have been released actually. All scores have released. Okay, hope you guys got it in your mail. Okay, I'm just gonna call few names. Make sure everybody is there here. Gautam, Vijesh,